All right, well, good morning, everyone, and welcome back to another exciting day in mathematics. Woo, woo. Warm-up number 6 is on the screen. You notice for numbers 1 and 2, it simplifies what we did last week. And numbers 3 and 4, I'm just introducing where we're headed for the next session. I just want to see where you're at, bringing it back little by little. Also, at the end, make sure you set up a Cornell note, just like that. I'll give you guys some time. Ready and go. All right, here we go. Y'all ready? Yes, thank you. All right, being that it's Monday, who goes over it on Monday? Let's go. All right, here goes number 1. I got 17 minus 8 plus 2. Now, in passing, I didn't get into this part, but here goes. Whenever we have this situation like this, look up. When we have a negative and then the number, I said group that and put a little plus sign in front of it. So like that, we have pluses all the way through. Does that make sense? From there, we combine like terms. So we got 17 plus 2, that's 19, plus negative 8. Question, could we cancel these 8 negatives with 8 from over here? Yes, and that leaves us with 11. Let's go. Oh, yeah, we got this. Again, here's another negative right here for the number 2. Group it, put a plus. And do we have addition all through? Here, 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 and here. Yes, combine like terms. Negative 2x, negative 5x, that's negative 7x. But we have a different variable now, negative y, and then negative 4y, that's negative 5y, yes? But then plus 2, so let me write that out. Negative 5y plus 2y. Question, can 2 of these cancel 2 of those? Yes, so that leaves us with plus negative 3y. Good review, yes? All right. Let's go to number 3. Let me make some space here. It reads, negative 46 equals to 23 plus x. Now, we're going to get into this session starting tomorrow. I'm just bringing them back. But I like to approach it like a balance scale. So I draw a line down the equal sign. And I need to leave the variable by itself. Where's my variable? Right here. What's next to it? A positive 23. So to get rid of it, we do the opposite. What's the opposite of positive 23? Negative 23. We do that to both sides. That leaves us with negative 46 and negative 23. That's negative 69. And all that equal to x. They're like, Q, just give us a pop party already. Let's go. So far, so good, yes? Let's go to number 4. Also, for number 4, same idea. Line down the equal sign. Here's x. What's next to x? 8. What is it doing? It's multiplying. So to get rid of it, we do the opposite. What is the opposite of multiplication? Division. Division, we do to both sides. 8 divided by 8 is 1. That leaves us with 1x. Negative 40 divided by 8, that's negative 5. Like I said, we'll get into that as soon as we can. So with that said, send me your warm-up. I want to see what you did. Copious notes. All right, you're sending that in. Copy the agenda, please. Warm-up number 6. Number sets and expressions. And tonight's home play, only 8 problems. Only. Thank you very much. Here's the code for your home play for tonight. Copy that. 64A 3C. 64A 3C. Also, this lesson's being recorded, so it's going to be uploaded on YouTube after lunch. So make sure if you are missing anything, go to the YouTube channel, revisit that. Also, just FYI BTW, I think we're going to be starting tutoring next week, so keep that in mind for those of you that need the extra support. Aside from that, we don't need to wait that long. I'm here in the morning. I get here like around 6:45, 7 in the morning. So if you need, if you have questions from your home plate, if you have any doubts of whatever we're doing, come see me, okay? But after school, we're going to start next week as well. Thank you, Mr. Q. You're welcome. I got you. All right, so previous home play, I gave you guys the weekend off. This is what the home play is going to look like tonight. Woo! Let's go. Yeah, we got that. All right, here we go. Our objective for today, I can simplify algebraic expressions. Today we're going to wrap this up. We're going to wrap this up. See what it did there? Where'd it go? Showing you, I got this. And we're just going to recap what we did last week just to make sure we got it and close this section off because we're about to move on to better stuff. Some of you are still kind of like dragging the weekend. Let it go. Let it go, guys. All right, here we go. So do me a favor. Turn your notes over. You're not going to need them for this next portion and see how much you remember. All you need to do is get help from your neighbor. They know it all, so just ask them. And if you have any doubts at the end, just ask Joseph. Joseph's got it. All right? Here we go. With that said, let's revisit what we saw last week. Look up. Algebraic expressions. We know what they are, what they look like, what they don't. However, expressions. Think about expressions. Are we there? I said we cannot solve expressions. We can do three things to expressions. Think about it. What were the three things we can do? Talk it over to your neighbor. What are the three things we can do to expressions? See if they remember. What three things can we do? Three things can we do? All right, write it on the screen. Get your text tool in front of you. What three things can we do to expressions? What do you think? If you remember, what three things? Since you already talked it over. Since we can't solve them, there's three things we can do. 3, 2, 1. Hands off keyboards, look up to the screen. Let's see. What three things? Translate, evaluate, and simplify. Some of you wrote it in different order. That's fine. But those are the three things that we can do. Why? Because they're not equations. That means we can't solve them, right? All right. Good. So far, so good. Next, think about this one. Again, no notes. Talk it over to your neighbor. Let them know what goes what under real numbers, what goes under imaginary, and what goes under complex. No notes. Just your neighbors. Use your neighbors. Talk it over to your neighbor. What would you write underneath here, here, and there? Talk it over to your neighbor. Look up to the screen. Did you write something like that? Real numbers are two sets, rational and irrational. Remind your neighbor what rational numbers are. What would be a definition? Numbers that can be written how? Tell your neighbor. Numbers that can be written how? Jesus! Rationals. They can be written Let's go. As fractions or decimals, that is correct. That means the irrationals cannot be. All right? Imaginary, square root of negative 16. Tell your neighbor what that is in imaginary. Share with your neighbor. What is square root of negative 16? All right? Let me give you another one so you can write on your screen. Square root of negative 49. Change that to imaginary, please, on your screen. Write that in there. What is square root of negative 49? Correct answer. Square root negative 1 times 49. Square root of negative 1 times square root of 49. Square root of 49 is plus minus 7. Square root of negative 1 is I. And we got that. Oh yeah, we got this. So far so good? All right, lastly, I want you to write me a complex number. Write me a complex number. Write a complex number. When you write it, tell your neighbor what a complex number is. What is a complex number? Ten, 9, 8, 7, 6, 5, 4, 3, 2. Here goes a complex number from one of your colleagues on your screen. That is correct. Tell your neighbor why that one's correct. Why is that one a complex number? All right, good communication. How about that one? Yes. How about, oh my goodness. It didn't come out? Oh, really? Oh, my bad. How about, yeah, all right. Here goes another one. All right. So far, so good, yes? All right, so from there, we moved on from sets of numbers. We moved on to algebraic expressions just to focus on that. So, without looking at your notes, tell your neighbor what are, in your own words, what are algebraic expressions? Think about it. What are algebraic expressions? Talk to your neighbor. What are algebraic expressions? What are algebraic expressions? All right, on your screen, give me a definition in your own words. What are algebraic expressions? Example, non-examples, please. One of each. Go. All right. Let's see how we did. Expressions that contain variables, constants, and operations. Examples, non-examples. Coming back little by little, yes? All right. So, open up your notes really quick. We're going to continue with the practice that we started on Thursday, Friday. Write example Q. All right, here we go. Write this down. Negative 2x. Oh, let it go. Negative 2x plus 5 minus negative 2x plus negative 3. Let's see how you do with that. Go. Kenyon's got it. Kelly's got it. All right, for the sake of reviewing really quick, look up to the screen. What is the first thing we do, guys? We check to see if there's addition throughout. Is that correct? So, this is a subtraction. So what is negative times a negative? This becomes a what? Positive. Next, start with the x. We have negative 2x. This is a positive 2x. What happens? It's a 0. They cancel. One is positive, one is negative. We're left with what? 5 plus negative 3. Those two. Can 3 of these cancel 3 of those? Yes. Answer 2. Hands if you got that by yourself. Okay, good. All right, let's do another one. Example super cube. negative 4y plus 7 minus, parentheses, negative 3 plus 6y plus negative 3. See how you do with that? Go. All right, let me make some space as you're finishing off, explain to your neighbor. Here we go. So first things first, check to see addition throughout. Is there addition here? No, we changed this to addition. Negative times a negative becomes a positive, and that's it. All right, let's start with the variables. We got negative 4y and positive 6y. This is negative, this is positive, so therefore can 4 of these cancel 4 of those? Yes, and that leaves us with 2 positive y's. All right, next. Do we have any zero pairs, guys, or any opposite numbers? Yeah, positive 3 and negative 3, they cancel, and that leaves us with plus 7. And have you got that? Okay. All right, not bad, not bad. Good warm-up, yes? Okay, let's crank it up a little bit, yeah? Here we go. Example MJQ. Let's go. Here we go. 1 plus 3x plus negative 4 plus 2x plus negative 1 plus parentheses negative 3x plus 6. Go down by yourself. Let me send you a screen. As soon as you're done, send me your notes. Go. Shazam Q, 7y minus 3 plus negative 2y plus negative 2. Yeah, I just sent it in. All right, show your neighbor, see what you got. All right, looks like Caitlin's got it. Very good, Caitlin. But I'm going to go over this one just to get rid of this doubt that we have. Look up to the screen. So, is there addition all the way through? Yes, yes, no. What do we do whenever there's a number and a subtraction sign? I said group it and put a plus next to it. So I wanted to bring one of these in. Okay. So, with that said, let's start with the variables. What is 7 minus 2? 5y, that is correct. Next, negative 3 and negative 2. Since they're the same sign, we just combine them. That is positive negative 5. And so on and so forth. Okay? Now, in passing really quick, look up on the home plate. Some of you are sending me your stuff in. That's cool. On the home plate, I'm going to give you stuff that looks like this. Watch. 4 parentheses 3x plus 2 minus negative 3. Look up. Whenever you have a parentheses with more stuff inside and there's only a number in the front, you need to multiply that number to anything inside of the parentheses before you actually do the next step. So here it would be what? 12x plus, what is 4 times 2? 8. This becomes a what? Plus 3. And the rest is history. Bring down the x and bring down the 11, and we are done. Yeah. Copy that example so you can have it handy in case you bump into one of those on your home plate. Write this as example Star Wars cube. All right, for those of you following along on YouTube, I'm going to give you guys time to go and get your practice in. You guys have the code for the home plate. I'm going to stop the video right there. Talk to you guys later.